Have you ever looked up at a perfectly clear blue sky and just wondered, what exactly is hovering up there above us? Well, today in this explainer, we're going to take a pretty wild journey together. We're traveling from the absolute freezing, pitch-black edge of space, straight down through these invisible, totally vital shields that protect us every single day, all the way down to the ocean's surface. That's where some of the most devastating cyclones on Earth are born before they hit our shores. So, buckle up, because we're going to completely demystify our planet's atmosphere.
Okay, here's our roadmap for today. We're going to kick things off with what breathes life, then take a journey through the layers, check out the vital ozone shield, witness the birth of a cyclone, and finally wrap up with devastating storms and surges. Let's get right into it.
What breathes life? The invisible ocean of gases we survive on.
Now, it's super easy to look up and just see empty space, right? But the reality is we are basically walking around at the very bottom of this massive, life-giving ocean of gases. Nitrogen absolutely dominates the mix at roughly 78%, with oxygen coming in second at nearly 21%. Everything else, just a tiny little sliver. Argon is hovering around 0.9%, and carbon dioxide is a microscopic 0.04%. But hey, don't let those tiny numbers fool you for a second. These exact, highly specific proportions are literally the perfect recipe required to sustain life, regulate our planet's temperature, and, just allow plants to absolutely thrive.
And that brings us to a frankly mind-blowing number, 5.5 times 10 to the power of 15. That is 5.5 quadrillion tons. Seriously, wrap your head around that. Thanks to gravity, this colossal physical weight is just constantly pressing down on the Earth. If you're standing at sea level right now, that translates to almost 15 pounds of pressure pushing on every single square inch of your body. We don't really feel it, but we are literally living at the very bottom of an incredibly heavy, dense ocean of air. Moving right along to Section 2, Journey Through the Layers, climbing the multi-story building of the sky.
So think of the atmosphere kind of like this intricately designed multi-story building. We hang out right down on the ground floor, which is called the troposphere. This bottom layer might be thin, but it actually holds a whopping 75% of the entire atmosphere's mass, plus almost all of its water vapor and dust. It's basically where all our weather happens: clouds, rain, storms, the whole shebang. But as we ride the elevator up through the stratosphere, the mesosphere, and the thermosphere, well, every single one of those floors serves a vastly different, absolutely crucial purpose.
And here's where it gets kind of wild. As we go up, the environment doesn't just get steadily colder the closer we get to space. Not at all. The temperature actually swings back and forth like a pendulum. In the troposphere, as you climb, it drops down to a freezing minus 56 degrees Celsius. But step out onto the next floor, the stratosphere, and it inexplicably warms right back up to about 0 degrees. Go higher into the mesosphere, boom, it plunges to an incredibly bitter minus 92 degrees. And finally, way up in the thermosphere, intense solar radiation blasts the super thin air, causing temps to just explode to over 1200 degrees Celsius. How crazy is that? Section 3. The Vital Ozone Shield, our planetary UV panic room.
Okay, so you're probably wondering, why on Earth does the stratosphere suddenly warm up while the layers right above and below it are freezing cold? Well, hiding right there in the stratosphere is the ozone layer, and this thing acts as a literal, physical shield for the entire planet. The reason that specific layer warms up is because those ozone molecules are hard at work absorbing the absolute most dangerous ultraviolet radiation from the sun, specifically those nasty UVB and UVC rays. So, by soaking up all that intense solar energy, the ozone layer heats up the surrounding air, while, simultaneously saving our lives down here.
Because, let's be real, if this shield ever fails, the consequences are immediate and catastrophic. With the ozone layer, humans, animals, plants, we all thrive safely. Without it, severe UV radiation would just completely bake the surface. We'd see massive spikes in severe cataracts and blindness, human immune systems would be drastically weakened, and plant life would be completely devastated, which, as you can guess, would instantly disrupt the entire global food chain. It's literally our planetary panic room.
All right, let's look at Section 4, Birth of a Cyclone, when the troposphere's energy becomes unstable.
So the stratosphere is busy saving us, but it's definitely not the only place where some seriously dramatic atmospheric physics is going down. Let's take that elevator back down to our ground floor and walk through the exact recipe for a cyclone. Because when the immense heat and pressure differences in the troposphere get unstable, literal monsters are born.
First thing that has to happen, the ocean surface temperature needs to hit at least 27 degrees Celsius, or about 80 degrees Fahrenheit. All that intense heat causes massive amounts of ocean water to evaporate, creating this deep, deep pocket of low pressure right at the ocean's surface. Next, the surrounding high-pressure air violently rushes in to fill that void. As all that warm, moist air is rapidly forced up, it cools and condenses, which releases even more heat. And finally, the Earth's rotation kicks in, specifically the Coriolis effect, and it causes this gigantic column of rising air to start spinning.
And when that seemingly simple recipe of heat and pressure scales up, it creates a massive, incredibly violent vortex. You can clearly see that distinct, almost terrifyingly calm eye of the storm right in the center. That's actually formed by the sheer centrifugal force of those violently rotating winds. Winds that, by the way, can reach absolutely devastating speeds of 250 to 350 kilometers per hour.
Now, the physics of these massive storms are universally the exact same, but the names we give them actually change depending on where you happen to live. Over in the Indian Ocean, they call them cyclones. Up off the coast of Japan, they're typhoons. Over near Mexico and the US, we call them hurricanes. And down in Australia, they historically went by the totally non-threatening name Willy Willies. But listen, no matter what you call them, they are a terrifying, awe-inspiring display of the atmosphere's raw, unbridled power.
Section 5. Devastating storms and surges, the human cost of atmospheric physics. Because when all this intense atmospheric physics finally meets human geography, the results can be deeply tragic. The Bengal region, and particularly Bangladesh, has just suffered immensely from these storms over the years. When we hear about cyclone damage, we usually instantly think of the wind, right? But the real, often hidden threat is actually the storm surge. This is a massive, totally abnormal rise in sea level that's purely driven by those intense cyclone winds. As the extreme low pressure literally pulls the ocean surface up, the violent winds push this massive, unstoppable wall of water far inland. And in so many cases, it's actually this wall of salt water that causes the most catastrophic structural and agricultural damage, just completely sweeping away homes, livestock, and entire forests.
And history paints a really grim picture of just how much power is escalating along the Bangladesh coast. Just look at the progression. You go from the Bola cyclone back in 1970 with winds of 222 kilometers per hour to Sidran in 2007 hitting 260, all the way up to Ampon in 2020 reaching a staggering 280 kilometers per hour. And the heights of those storm surges are equally terrifying. We're talking about literal walls of water, 15 to 22 feet high, just rushing onto heavily populated coastlines.
I really want to just pause on this number for a second. 500,000. 500,000 lives. That is the estimated number of people who tragically lost their lives during the Great Bola Cyclone of November 1970. It's a really sobering reminder that the atmospheric forces we're talking about today aren't just abstract science. They have an immense, real-world human cost.
And honestly, that leaves us with a pretty critical thought for the future. We learned in our explainer today that a sea surface temperature of over 27 degrees Celsius is the primary trigger that gives birth to a cyclone, right? So, as global sea surface temperatures continue to rise all around the world, how exactly will our shifting atmosphere reshape the devastating storms of tomorrow? It's really a delicate question of balance between the incredible protective layers that shield us every day and the violent atmospheric engines that continually test our resilience. Thank you so much for exploring the sky with me today. Stay curious, and as always, keep looking up.